All right, here's some further explanation on some of the problems that I thought were tricky. We're going to start at the red star. So the reason why I thought that this one might have been a little tricky for you is because we didn't learn how to do anything with division or rational functions or anything like that, right? So we're going to approach this just like we would when we were first learning derivatives, where we try to rewrite everything as one coefficient raised to one power so we can use the reverse power rule that we've been talking about so far. So I would rewrite this guy as x over the square root of x plus 1 over the square root of x dx. And this rewritten with fractional exponents would end up being x to the first. In this case, we're going to be subtracting off a 1/2, so I'm going to do x to the 2 over 2 minus 1/2 plus, and then I would have x to the negative 1/2 dx. So our starting integral is now going to be 2 minus 1 is 1, so I have x to the 1/2 plus x to the negative 1/2 dx, and then now I begin integrating. So I take the first piece and I have 1/2 plus 2 over 2, that's going to give me 3 over 2, and then I will divide by the new exponent. Plus x to the negative 1/2, I add 2 over 2 equals 1/2, and I now divide by the new exponent with my plus c. So now I'm going to just clean it up. I have 2/3 x to the 3 over 2 plus division by a fraction is the same thing as multiplication by its reciprocal. So I'd have 2 square root of x plus c. Okay, and if this isn't the problem that you came for, you can either scroll ahead or, skip ahead to the one you want, but I'm going to pretty much be doing this one, and this one with the remainder of this video. So negative 2 over x plus 3 e to the x dx. I can integrate 3 e to the x, no problemo, but for the other one, I am going to have to probably consult my rules that I just learned about, okay? So if I were you, I would scroll back and be like, okay, I definitely saw all these listed out here, and okay, I see that the integral of 1 over x dx will become the ln of the absolute value of the argument here. So, okay, that is what I'm going to do. So I see that I can pull out any constant that I would like. So I'm going to go ahead and pull out a negative 2, and then it becomes very clear like what I'm trying to integrate here. And then I'm going to pull out a 3, because then it becomes really clear what I'm trying to integrate here, okay? And here, now I'm going to have negative 2 times the ln of the absolute value of x plus 3 e to the x plus c. That's it. So you can pull out the constant or don't pull out the constant, whatever you prefer, whatever is easier for you. So this next one here is going to be the exact same as the one above, right? I see a ratio of two polynomials. I'm like, wait a second, I don't know how to do that yet. I'm going to look for a way to rewrite these so that way I can write singular powers of x and have singular coefficients. Okay. So now I'm going to combine these. When I divide like bases, I subtract the exponents. So I'm going to have x to the 4 over 2 minus 1/2. And then minus, I'm going to rewrite this as a negative exponent here. Okay. So then now I'm going to be integrating x to the 4 minus 1 is 3 over 2 minus 2x to the negative 1/2. dx. Okay, this is great. I get to use my reverse power rule now. I would have x to the 3 over 2. I add 1, and then I divide by the new exponent. Okay, and then, oh, sorry, it's a minus. Oh, actually, hold on, let's see. So, yeah, I would have negative 2x, and then I have a negative 1/2. I add 1. I get 1/2, and I divide by the new exponent plus c. So now I'm going to have x to the 5 over 2, but I'm dividing it by 5 over 2. So now I'm going to be multiplying by 2 over 5, x to the 5 over 2 minus the 2 times the square root of x, and then divided by 1/2 is the same thing as times 2. Wow, lots of mental math to keep track of here. Okay. That one's all set. Perfecto. Let's go to the next one. I'm multiplying this whole thing inside the integral by 4. Oh, the 4 is so coming out. All right, there we go. Now I've got this. Okay, this is pretty easy. I'm just going to work piece by piece now. So I've got 4 times, and then remember, I've pulled it out of the whole integral, so whatever I end up with in here, I got to be tacking on at the end. The integral of 1 over t is going to be the ln of the absolute value of t, and then minus 2t to the 3 plus 1 divided by 4 plus e to the t, and then plus c.